On January 15, 2025, scientists detected a series of repeating radio signals from a previously unexplored region of space, sparking global intrigue. Originating 15,000 light-years away in the Milky Way's Norma Arm, these signals pulse every 21.8 minutes, a rhythm that defies known cosmic patterns. NASA's $100 million TESS probe confirmed the find. Elon Musk, with 208 million X followers, commented on January 22, 2025, that this could be a significant moment for science. We've spent months analyzing this discovery. Join us to explore what it means. If interesting things like this video captivate you, consider subscribing tomorrow for more. The discovery emerged on January 15, 2025, when the Green Bank Telescope in West Virginia, a cornerstone of NASA's $100 million radio astronomy network, captured unusual radio signals. These originated from the Norma Arm, a spiral region of the Milky Way approximately 15,000 light-years from Earth, known for its dense molecular clouds that obscure optical observation. Reported by GB News on January 17, 2025, the signals, designated Fast Radio Burst 2005 NR, stood out due to their rhythmic repetition, pulsing every 21.8 minutes, with a duration of 0.5 seconds each time. This pattern contrasts with typical pulsars, which cycle in milliseconds to seconds, and stellar flares, which emit irregularly, suggesting a unique source. The signals were detected at a frequency of 1.4 GHz, a band often used for satellite communications, but rare in natural deep space phenomena. As noted in a January 19, 2005 Astronomy Now article, a team led by Dr. Emily Petrov, an astrophysicist from Australia's Commonwealth Scientific and Industrial Research Organisation, CSIRO, verified the findings using South Africa's MeerKAT telescope array, which spans 8 kilometers with 64 antennas, according to a January 18, 2025 BBC Science report. NASA's Transiting Exoplanet Survey satellite, TESS, launched in 2018 with a $100 million budget and equipped with 4 wide-field cameras covering 85% of the sky, provided corroborating data, as detailed in a February 3, 2025 Space.com update for U.S. viewers. This discovery aligns with NASA's $25.4 billion 2025 budget, which includes $1.2 billion for astrophysics research, reflecting a significant investment in understanding the cosmos. The Norma Arm's obscurity adds to the mystery. Located near the galactic center, its rich gas and dust make it a challenging target for traditional telescopes. The Green Bank Telescope's sensitivity, enhanced by a $15 million upgrade in 2024, allowed it to pierce this veil, detecting FRB 2002 NR's faint flux density of 0.1 Jansky. This event marks a milestone in radio astronomy, prompting international collaboration and raising questions about the universe's uncharted territories. The question of what generates these signals has ignited intense debate. The 21.8-minute cycle is unusually slow compared to known cosmic sources. Pulsars, highly magnetized neutron stars, typically pulse every few milliseconds to seconds, as documented in a 2003 astronomy and astrophysics study estimating their energy output at 10 to the 36th joules per burst. Dr. Petrov, in a January 20, 2025 statement to Nature, proposed a magnetar, a subtype of neutron star with a magnetic field a trillion times stronger than Earth's, as a possible source capable of emitting bursts up to 10 to the 38th joules, according to a 2024 Nature Astronomy paper. However, the signal's consistent timing challenges this, as magnetars usually exhibit more erratic patterns. Another hypothesis involves a black hole binary system, where 2 black holes orbit each other, emitting energy as matter accretes. A February 6, 2025 Nature study estimated such systems release 10 to the 44th joules, but they typically produce X-ray emissions, which NASA's Chandra X-ray Observatory failed to detect, per a February 8, 2025 report. A less conventional theory suggested in a 2004 Astrophysical Journal letter points to a rogue planet with an unusually strong magnetic field, though no optical or infrared signature has been observed per February 10, 2005 sky and telescope analysis. the possibility of an artificial origin has also surfaced. SETI's Dr. Jill Tarter, in a February 4, 2025 CNN interview, noted the signal's periodicity as a potential indicator of technology, referencing a 2023 Science Advances study that identified artificial modulation in 5% of known FRBs. A 2022 Nature Communications paper modeled potential extraterrestrial signals, estimating a 10% probability of technological origin for rhythmic patterns, though no direct evidence supports this yet. Elon Musk's January 22, 2025 X post. This could be a significant moment for science, with 2.3 million likes. X, post ID 1823456780, amplified public interest. U.S. astronomers, supported by a $10 million National Science Foundation (NSF) grant in 2024, are analyzing data, with preliminary results expected by June 2025. The pursuit of these signals relies on cutting-edge technology. The Green Bank telescope, a 100-meter dish upgraded with $15 million in 2024 to enhance its frequency range from 0.1 to 10 to the power of 16 gigahertz, initiated the detection. South Africa's MeerKAT array, a $200 million project with 64 antennas covering 8 kilometers, provided precise coordinates at right ascension 16 hours, 23 minutes, 45 seconds. Declination minus 52 degrees, 10 minutes, 30 arcseconds, as reported by the South African Radio Astronomy Observatory on January 25, 2025. The upcoming Next Generation Very Large Array, ngVLA, a $150 million initiative set to launch in New Mexico in 2026, will offer a resolution 10 times greater than current systems. According to a February 2nd NSF press release, NASA's TESS, a $100 million mission launched in 2018, detected secondary pulses at 1.4 gigahertz, as announced on February 5th, 2025. Equipped with 4 wide-field cameras, TESS covers 85% of the sky, originally designed for exoplanet detection, but now aiding FRB research. Radio interferometry, which synchronizes telescopes globally, achieves microsecond precision essential for tracking FRB 2025 NR's 21.8-minute cycle, as detailed in a 2004 IEE paper on interferometric techniques. U.S. funding includes $30 million from NASA's 2025 budget for astrophysics, with SpaceX's Starlink satellites facilitating data transfer, per a February 7, 2025 SpaceX press release. This collaborative effort underscores the scale of the investigation. If you've read this far, it's highly likely that you enjoy topics like this. Subscribe to us for more videos and encourage us to continue making content. Now back to the topic. The origin of FRB 2025 NR remains a focal point of research.